Alright guys, so in the last section we talked about classes, how we can create instances of classes, we talked about inheritance, abstract classes, open classes and interfaces. In this section we're going to talk a little more about classes as well, but we're going to start with the feature called single abstract method interfaces. Now what do I mean by that? So let us first define an interface with the interface keyword, and we will call this logger, and give it a function here called log. So it has an abstract method called log. Also let's have another function here which is non-abstract, and just to make it non-abstract, just give it an empty body. So as you can see, there's just one abstract method in here. So this is the qualification that this interface can be turned into a functional interface. How do you do that? Well, you'll use the function, the fun keyword right in front of it, and you can define an object for the logger. So let's say we do not have this as a functional interface. The normal way to make an object of type logger would be, let's create an object here and call it logger, and use the object keyword which will be of type logger, and then override the function in it. This will be log, and then execute some logic in it. Since it does not return anything, you don't have to return anything in here, just execute some println statement in it. Actually, let's make it return something, and what you would do here is return some value, true or false. This will be of type Boolean. There you go. So if this was not a functional interface and was just like a normal interface, this is how you would define the object type logger using the object keyword and then override the function in it. But since this has just one abstract method in it, I can define this as a functional interface. So let's do that. And as you can see, it gives you a hint that you can convert this to a lambda. So let's do that. And it looks much cleaner. So all you have to do is use the type and then use it as a lambda, execute some logic, whatever you want to do, and then the last statement, which will be the return statement, will be the type the abstract method has. You can have as many non-abstract methods in here, but the qualification for an interface to be a single abstract method interface would be that it should have just one abstract method. So Kotlin allows you to define nested classes and inner classes as well. Let's take a look at that next. So let me first delete this code and make this interface into a class called logger. And the way to define a nested class is just straightforward using the class keyword. Let's call this class backend logger. So you would define a nested class primarily when you have things related to the outer class. And so in this case, I defined a nested class called backend logger, and this class can have its own properties. So let's give it a property called constant and give it a value of -1. It can also have functions. So my nested fun. This can operate just like a normal function. It can have a return type. In this case, let's not have a return type. Print ln and just print some statement there. And the way to create an object for the inside or the nested class is using the dot operator. So let's create an object first. And we will use the dot operator on the outer class, just like that. And this object can now access the properties of the nested class just like normally, just like that. So this nested class is kind of like what refers to as static in Java. So you use the dot operator on the outside class. You can make this into an inner class, which will give it access to outside properties. So let's say my outside class has a property called outside prop, and then give it some value here. Now, if I try to access this property from my nested class, that is not going to work. The compiler is going to throw an error. So if I do this, it's saying that it does not recognize this property because this nested class does not have access to the outside property. In order to do that, I will have to make this class inner. So if I make this inner, now my inner class will have access to the outside property, and this will work just fine. And in order to make an object of my inner class, I would have to create the object of the outer class and then use a dot operator to create the inner class object, just like that, and that would work just fine. So you can even define interfaces. So let's delete this. Let's create an interface here called front-end interface. I'll just call it front-end logger, and give it a function here called log. So as you can see, the interface will have an abstract log method here. You can define more non-abstract methods. So log more, just like that. Give it values or print something. And in order to create an object of this, you would have to use the object operator or the anonymous operator. So let's delete this. Let's create an object of the inner interface, front-end logger, and define this using the object, just like that. And then implement the members, which in this case is log. So now that you define this, let's execute some logic in it. So log front end, and you can even pass this as an argument to another function. So let's say I have another method called log front end in another class or sitting somewhere else. You can pass that as an argument. So this will be of type logger of type logger dot front end logger, and then I can just go ahead and use any of these methods inside that interface. So if I run this, this is not going to do anything because it'll just create an object of that, and I am not calling this method. So let's go ahead and run this. Nothing happens. However, if I want to do something useful with this, I could call this front end logger with the type mylogger, just like that. Let's run this, and now it logs the front end. So essentially what I did here was I created an object of the type interface, which is the inner interface here, defined in a class called logger. And what I did was I overrode the function log inside it. I executed some logic in it, and then I executed a function passing in the logger object, which is of that type interface. And this function did the work for me of actually doing something and then logging that log method right there. So take some time, think how this works through. This is really useful, makes your code clear and concise and easy to understand once you get used to it. So you would often find yourself moving data around, like in a data transfer object. You can encapsulate them in a class. However, Kotlin provides a utility class just for that purpose, and it's called data class. The way you'd want to declare a data class is use the data keyword and use the class keyword, of course. So let's make a data class called employee. Obviously, employee will have a lot of fields, but for our purpose, we will just create an employee with just few fields. So the first thing you can think of for an employee is an ID, which will be of type int. In real life, it would probably be a string or something more complex, hash code stuff, but for this case, we're just going to use an integer. And then also let's use an employee name of type string. Now, the criteria for declaring a data class is the primary constructor should have at least one parameter, and each of these parameters could be either val or var. Obviously, it's a good practice to make immutable data classes, so you can just pass them around without making any changes to it. If you want to change, you could use the copy function. However, in this case, so when you declare a data class, there are certain things that happens. ToString, hash code, all these methods are assigned to this. And there's also a useful feature called component end functions. What do I mean by that? So let's first create an object for employee. and we'll give him an ID of 1 and a name, let's say Jack. You can name this function for better naming conventions, so you could do a name equal to this and then ID is equal to this, so it refers to that. Obviously you can name it as in any order, so just like that, and that works as well. So in this case, the component 1 is ID, so let's go ahead and print the component. So print ln and employee dot component 1, and let's see what happens. So the component ordering is essentially the type where you've declared. So I've declared the ID as the first parameter, so component 1 is ID and component 2 is this, and so on and so forth. You can declare as many components as you can. So one of the useful things about this is you could use destructuring. So you could use parameters like ID, name, and then use your data object, and then use these in your program. So let's print the name. Pretty much like that. I can create an employee copy object, so I can create another employee. So let's create employee 2 who, let's say, has the same name but a different ID. So let's create him from the first employee and dot copy, and we will just give him an ID of 2 and everything else remains the same. Now if I try to print this employee, so there is a toString mechanism, toString method that's generated for this, and for our employee 2, when I print a toString, it prints the ID and the name remains the same. Remember, we did a copy, so we essentially created a new object and added an ID or replaced the ID with 2. We can replace the name as well, and that's how it works. So essentially a copy function. So it's a good thing to use data classes as opposed to just generating an entire class just for doing this. In Java, you don't have an option, you don't have anything like data classes, so you have to generate the employee object. You have to make an employee class with getters and setters. In Kotlin, it's super easy to do this. And pretty much that's what data class is. So whenever you're passing object around, use a data class.